Hello everyone. In this video, we are going to discuss about periodic properties. In our previous videos, we have discussed about the modern periodic table, how the elements are arranged in the modern periodic table, and reasons for placing F-block elements at the bottom of the periodic table separately. Now, let us discuss about the periodic properties. What are periodic properties? The properties of the elements in the periodic table which repeats regularly after a particular time interval. If you start from a particular element, say lithium, after a particular number of elements, that is metallic property, will be repeated in the same case of sodium. Right? So starting from lithium, exactly after 8 elements, the same property is being repeated. That is metallic property in the form of sodium. So in this way, such properties which repeats regularly at a particular time interval are known as periodic properties. Now we are going to discuss about the 5 periodic properties, and in this video we will be discussing only about atomic radius. And we have 5 major periodic properties. They are atomic radius, valence, ionization energy, electronegativity, electron gain enthalpy, or which we also call as electron affinity. Now let us see about atomic radius. What is atomic radius? You all know the radius starting from the distance from center of a circle to the its edge is known as center, is known as radius. In the same manner, in an atom, you all know that nucleus will be there with neutrons and protons in it, and that nucleus will be surrounded by electrons in a particular number of shells. The distance from the center of that nucleus to the outermost valence shell is known as atomic radius. What is atomic radius? The distance from center of the nucleus to the outermost valence shell. See, if you take this as an atom, the distance from here, the center of the nucleus to the outermost valence shell is known as atomic radius. So how this atomic radius is going to vary in the groups and in the periods of the periodic table, let us see now. And this atomic radius is used to compare the sizes of the elements in the periodic table, how they are going to change, how the particular group elements, what is the size of the particular group elements, what is the size of the particular group elements, we can compare by using this atomic radius. And actually this atomic radius is very difficult to find. So we will be taking the average distance of the 2 bonded atoms. So if you take any covalently bonded atom like hydrogen or any other chlorine or fluorine, so we will take the average distance between these 2 bonded atoms, and then we will be considering it as atomic radius. This atomic radius is measured in picometers. The units of measuring atomic radius is what? Picometers. 1 picometer is equal to 10 to the power of minus 12 meters. Now coming to the variation of this atomic radius in the groups and periods. Coming to the groups. See, in the groups from top to bottom, what happens? As we move from a particular element to the next element, the shell number increases. So if you take a first group elements like lithium, sodium, potassium, rubidium, cesium, francium. In this, what happens? If you look at lithium, the valence shell is 2s here, 2, and the valence shell in the case of sodium is 3, and the outermost valence shell of potassium is 4. That means what is happening here in a group from top to bottom, the shell number is increasing. So what happens? Automatically the size of the atoms also increases. So we can conclude that in the groups from top to bottom, the atomic radius increases due to the increase in shell number. Why it is going to increase? It is increasing due to the increase in shell number. Okay. In the same manner, the thing is same for all the groups. Second group or third group or whatever it may be the group you take. In the groups from top to bottom, the shell number increases, so automatically the sizes of the atoms increases, which automatically increases their atomic radius. Next, coming to the variation in the periods. So in the periods, what happens from left to right? Atomic number increases gradually, but as the atomic number is increasing, the next coming electron will be entering into the same shell in a particular group. If you observe the second period elements, lithium, beryllium, boron, carbon, nitrogen, oxygen. In these elements, if you see, the electrons are entering into the same second shell. See, if you take the lithium, the outermost valence electron has entered into second shell, and in the case of beryllium, also it is in the second shell. Its electronic configuration is 1s2 and if you go to boron, the electron has entered into the same second shell but into the subshell p subshell. Earlier in these two cases s subshell, but now in the case of boron it is into the same shell with difference in the subshell, that is p subshell. Next, carbon also has entered into the same shell, that is second shell. So in a period, if you take the elements are having their outermost valence or their electrons in the same outermost shell. Okay, why with this what happens? The nuclear charge increases. See, automatically as atomic number is increasing means what? The nuclear charge increases. The number of protons also increases, which increases the charge of the nucleus. The positivity of the nucleus will increase. But the atom is entering into the same shell. The shell numbers are not increasing. The shell number is same. So with the increase in the nuclear charge, this nucleus will have more ability to attract these electrons towards itself. So therefore, in a period from left to right, the nuclear charge increases, which pulls the electrons strongly towards itself. So gradually, what happens from left to right in a period? The atomic radius decreases. Why it is going to decrease? Due to the increase in nuclear charge. Due to the increase in nuclear charge in a period from left to right, the atomic radius is going to decrease. Okay? So this is all about the atomic radius. In the next video, let us know how the atomic radius is going to vary in the case of neutral atoms and ions. Okay, when we remove or when we add an electron to an atom, it is going to get converted into an ion, that may be positively charged ion or negatively charged ion. So in these ions and in these neutral atoms, how the atomic radius is going to vary, right? And also we will see what is valence and how the valence is going to vary in the groups and in the period.